Okay, so today we are talking about the angle addition postulate. So if C is on the interior of angle ABD, so inside the angle, then the measure of ABC so this one right here, added to the measure of angle CBD, this one right here, is going to be, I didn't highlight that, is going to be equal to the measure of the entire giant angle ABD. So this one right here. Okay, so for my first example, I have that given angle JKL, if measure of MKL is 55, what is the measure of JKM? So MKL is the one I know this is 55. This other one is what I'm looking for. It's going to be X. And then does anyone know how many degrees are in a straight line? Okay, so how do I want to solve this? Yeah? Okay. I'm going to set this up as an equation first, and then I'll subtract. So I'm going to have x plus 55 equals 180, because I have the two angles added together, and I know they have to equal the original angle of 180, which we will subtract 55 from both sides. So what do we get when we take 180 minus 55? 1 what? So it's going to be 125, and if I'm writing this out, I want to remember to put the degree symbol. Because that one was an angle that I was looking for. Okay. Number 2 says the measure of angle DEF is 85, so this entire thing is 85. DEG is 3x plus 8. And FEG is 2x minus 3. So what two things do I want to add together? Nate? And then this is going to equal the 85 because the 85 was the entire angle. Then I just want to combine like terms. So what number do I get in front of x? And 8 minus 3? It still equals 85. So I get 5x equals, what's 85 minus 5? Okay, so then To get x alone, I want to and I get x equals, okay, was this question asking for x? Yes, it was. What's the value of x? So I'm done. And because it's asking for a letter and not an angle measure, I don't have to write the degree symbol. So number 3 says the measure of angle MNO is 15x plus 6. So that's not on this picture. Find the measure of MNO. So this one I want to set up. What two things am I adding together? And this is going to equal the 15x plus 6. So first thing I want to do is combine like terms. What do I get? Plus 16. I'm not moving the x's yet. I was just combining the numbers on the left side. Okay. Then if I move my 14x over to the other side, I have to subtract it. So 15x minus 14x is Okay, and then to get x alone, I want to subtract it. I get x equals 10. Is this what the question wants? Does it want me to find the value of x? No, I gotta plug back in. So I'm going to be plugging into which angle? MNO. So I'm going to do this over here. So I have 15 times 10 plus 6. What is 15 times 10? And then adding 6 is okay. Number 4 says the measure of angle GHI is 16x plus 7. That one's not on the picture. Find the degree measure of all 3 angles. So, first thing I want to do is I want to set this up using the angle addition postulate. Which 2 angles am I adding together? No, I only add 2 together. So I'm going to have 4x plus 7x plus 57, and then it's going to equal the third angle. So combining like terms on my left side, what do I get? Then I'm going to go ahead and subtract 11x from both sides. want to subtract 7 on both sides. And then to get x alone, I divide by 5. I get x equals 10. Was this question asking me to solve for x? No, I'm going to solve this down below the proof. So, first angle it wants me to find is GHJ. That one is 4x. So when I go to solve it out, I'm going to do 4 times 10. Then the next one I want to do is JHI. That one is going to be 7 times 10 plus 57. So what's 7 times 10? And 70 plus 57? So. Okay, so the last one I need to find is GHI. There's 2 ways I can do this. I can plug into the formula, or I can add the 2 I already know together. Which one do you want me to do? Formula or add the 2? Okay, I'll do the formula. What is 16 times 10? And then 160 plus 7? Okay, so since I used the formula, I should be able to double check my work by adding the 2 angles I got before together. Does 40 plus 127 give me the 167? Yep, so we did that correctly. Okay, so the next one gives me a proof and it wants me to solve it. It says, given measure of angle AEC equals the measure of angle BED, prove that the measure of angle 1 equals the measure of angle 3. And then it also gives me this picture. So my first statement is measure of angle AEC equals the measure of angle BED. What is always my first reason? Given. And if I look, that was the very first thing it said under given. Okay, the next thing I have is the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. So, this is what we learned today. This is the angle addition postulate. And I'm going to use the angle notation to save room. And I'm going to abbreviate postulate. Okay, the next one says the measure of angle 2 plus the measure of angle 3 equals the measure of angle BED. So, this one again, same thing, I'm adding 2 angles together to make a third angle. This one is going to be my angle addition postulate. Okay, my next one says the measure of angle 2 plus the measure of angle 3 equals the measure of angle AEC. So, on this one, from step 3 to 4, I just changed the angle name at the end. Is there something we've said already that allowed me to change those two angle names? Yeah. I used my substitution property, because that was the very first thing I said, was that those two angles were congruent. Okay, the next thing I have is that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. So from step 4 to step 5, I changed out the measure of angle C to be, or AEC, to be the measure of angle 1 plus the measure of angle 2. So again, that's going to be substitution because I replaced it. Okay, and then my last step, I have measure of angle 1 equals the measure of angle 3. How do I get rid of the measure of angle 2's from step 5? Subtraction. So I have this proof right here. It's not really a proof. It has this picture as my given, and my first statement is the measure of angle DEF plus the measure of angle FEG equals the measure of angle DEG. So when I'm adding two angles together to make a third angle, this is going to be my angle addition postulate. Because I added this angle to make that third angle. Okay. The next one says, given MN equals 12 and OP equals 12, prove that MN, line segment MN is congruent to line segment OP. And then I have this picture. My first step of the proof says MN equals 12, OP equals 12. What is my reason for that? Given. My next step just straight up says MN equals OP. How did I get rid of my 12? Not subtraction, because it's not one giant equal sign. There were two separate equal signs. So when I have two equal signs and I get rid of one, I replace the numbers. That's another word for replacing. Okay. And then I have line segment MN is congruent to line segment OP. To go from the equal symbol to the congruent symbol is typically a definition. So I'm going to say definition of congruent segments. And I'm going to use my congruent notation. On the next one, I'm given MN equals NP. I want to prove N is the midpoint of MP, and then I also have this picture. My first thing says MN is equal to NP. This reason is given. So if I go to my picture, I can draw my tick marks to show that those two are congruent. when I have two congruent pieces touching each other, the point in the middle has to be my midpoint. So I'm going to say N is the midpoint of MP. And this one again is going to be my definition, but this time it's the definition of midpoint. Okay. On this next one, it says, given the measure of angle x equals 40 and the measure of angle y equals 40, prove that angle x is congruent to angle y. So my first statement is going to be the given. So it's going to be measure of angle x equals 40, measure of angle y equals 40. And the reason is given. Okay, what do you guys think I should do next? I know that these two angle measures are equal. So what can I do when they're equal? Not yet. I'll get there. I want to substitute my 40s away. So I'm going to have the measure of angle x equals the measure of angle y. And this is my substitution property. Okay, now I can say, because I've actually written out that the two angles are equal, now I can actually say that they're congruent. So I can say angle x is congruent to angle y. And this is my definition of congruent angles. Have I proven what they wanted me to prove? Did I get angle x is congruent to angle y? Yes, so I don't need that last box. My next one says angle 1 and angle 2 are complementary, and angle 3 and angle 2 are complementary. Do you guys remember what the word complementary means? Huh? She's in my second R. Do you just want me to hold on to it? Oh, sure. So complementary means they add up to 90 degrees. The way I like to think about it is the word complementary and the word corner both start with C, and if I look at the corner of the paper, it's 90 degrees. So, what's the first thing I want to write? The given. So I'm going to have angle 1 and angle 2 are complementary, and I want to be able to fit the other one in the box too. Angle 2 and angle 3 are complementary. And my reason is given. Okay, so then I'm going to write the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And the measure of angle 2 plus the measure of angle 3 equals 90 degrees. Any idea on how I went from step 1 to step 2? This is my definition of complementary angles. Okay. The next thing I'm going to write is the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. How did I go from step 2 to 3? Substitution. Okay, so I see that I have the measure of angle 2 on both sides of my equation. I'm going to get rid of that. So I'm going to have the measure of angle 1 equals the measure of angle 3. What's the word for what I use to get rid of the measure of angle 2? Subtraction. So when I'm doing proofs, and it has this prove part in it, that should always be my last statement. Let's use proof. So I'm going to have angle 1 is congruent to angle 3. And how do I go from writing the m's out front to writing the congruent sign? Do you remember? Yeah, not segments, angles. Definition of congruent angles.